Hey everybody, this is Mr. Longo, and we are going to cover linear functions in this video. This should be very much review for you, but we're going to just talk quickly about how you can determine if something is a linear function just by looking at a table, and then write the equation of it, and a few other things like analyzing or solving for x. So, how do you determine if something is a linear function by a chart? And what you need to do is see if it has a common difference. So if we look at our x's, we're going up by 1 each time. So if it's linear, your x and y's will increase at the same rate each time. So this is going up by 3, this is going up by 3, up by 3, up by 3. So if they have a common difference, it is a linear function. So how do you write the equation from that? Well, by finding your common differences, remember your slope is your change in y over your change in x. So 3 over 1 is your slope. So we have m is equal to 3. Now remember, your b value is your y-intercept, which we already know means x is equal to 0. So if we have x is equal to 0, our b value is 0 comma negative 2, which means our b is just a negative 2. So our equation would just be y is equal to 3x minus 2. Now using this little method right here, if your first one wasn't the same, let's pretend after you did this it was 1, 2, 3, 4, but then you did it again and your common difference was 1 or any of the exact same number on the second step, that would be a quadratic. If it took you 3 tries, it would be a cubic. So that's how you can determine what type of a function it is. But for a linear function, it must have the common difference on the first try. So next we are going to do some solving for x. We're going to do it with just a few functions, and then we're also going to do it with a graph. So this one should be really easy for you guys to do. Basically, we're solving for x given a certain function is doing something. The first one, f of x, is equal to 0. So how do you determine what x has to be? You just set it equal to 0. 3x minus 2 is equal to 0. So add your 2 to both sides and divide both sides by 3, and x is equal to 2/3. Very simple to do. So why don't you try the next two and see if you can come up with x on your own. Give it a shot. So if g of x is greater than or equal to 0, all you do is negative 2x plus 6 is greater than or equal to 0. Subtract your 6 from both sides. Negative 2x is greater than or equal to a negative 6. Divide both sides by a negative 2, and you get x is less than or equal to 3. Yeah, you might have forgotten that whenever you divide by a negative with inequalities, you have to change the direction of the sign. But if you remembered, good for you. It's pretty awesome. F of x is less than g of x, so we're just going to set 3x minus 2 less than a negative 2x plus 6. Move your x to the left if that's what makes you happy, and then move your 2 to the right, so we have 5x is less than 8, so x has to be less than 8/5 for those equations to be true. Okay, so that's it with working algebraically with f of x, g of x. The last thing we're going to talk about is solving for x by reading a graph. So this is going to ask you what is x when y is equal to 10 is basically how you would read that. The function is equal to 10, so what does x have to be? So this just means y is equal to 10. So let's go find, here's y. Y is 10, x is 15 to make that happen. So x is equal to 15. So f of x is less than 0, which x values make that happen, and 0 is less than or equal to f of x is less than 10. Again, this is something you should easily be able to do on your own, so pause the video and give it a try, and we'll see how you did. So if f of x is less than 0, that means 0 and below. So we're starting with x is equal to 5, and below will produce a y value less than 0. So that means x has to be less than 5. And for the last part, from 0 to 10, y, or the function, is equal to 0 to 10 when x is 5 to 15. And remember to keep the same things. This should be less than. Look at me getting crazy. Anyway, that's working with functions and being able to solve for x. This is Longo and I'm out. See you, bye.